to start with questions? Okay, so we're just going to ask you a couple questions. But Zoe, go ahead.
Okay. So how did you get interested in meteorology and climate change?
Well, when I was a little kid, I was very interested in weather. According to my older brother, I used to crawl to the window when I was just a toddler every time there was a thunderstorm. So I later got interested in math and physics and found out that I could sort of put together those two disciplines with my favorite hobby and make a profession of it. And that's what I did. So I really started out understanding the physics of weather. It was the big goal. And later in my career, became very interested in climate.
Very interesting. So like what made you choose this path?
Well, my generation, I think, was they sort of followed their interests a lot as opposed to being strongly influenced by other motives like making a lot of money, so forth. And I was just interested because I was interested in weather. I thought, gee, this would be great to make a profession out of it. So I also liked interacting with other people in classrooms and so forth. So I kind of like teaching, and that's how it all happened. And no regrets, of course.
And how have your interests changed over time?
Well, they have evolved over time. I started out being very interested in small-scale weather phenomena, bands of rain and snow and winter storms, severe thunderstorms. I did a stint back in 1978, 79, filming tornadoes for the Nuclear Regulatory Commission, because they needed to know how strong winds were so they could build power plants that could withstand them. So I did a stint chasing tornadoes across the Texas and Oklahoma panhandles. But I later had to, or was asked to teach a course in tropical meteorology, and realized that my understanding of hurricanes was poor, and later discovered that the extant understanding was wrong, that people basically didn't understand how they work. So I set about to fix that, and I became very interested in the physics of hurricanes that way. Later on, I asked myself the question are hurricanes possibly affected by climate change? So I think I wrote the very first paper on that subject back in 1987.
And what have you found most fascinating in your hurricane and cyclone research?
Well, I always find nature fascinating, and the idea that, for example, that hurricanes are almost spookily efficient in extracting heat from the ocean and turning it into wind. There are all kinds of little revelations like that are really exciting over time. It'd be a hard put for me to pick out the one that was best, but there are quite a few moments, aha moments that were great.
And how do you combine physics and new technology to help aid you in climate change research?
Well, I think most of our understanding of climate change is actually based on fairly elementary applications of physical principles. And it's wonderful if you're in the midst of it. It becomes very problematic. I think it's the main thing standing between scientific community and the public understanding of climate change is that, you can show an intelligent person a graph, for example, that shows temperatures going up and carbon dioxide going up, and they get that. But if that's all you show them, they're going to naturally ask which causes which, or are they both caused by a third agency? That would be an intelligent thing to ask. Now you're faced as a climate scientist with the proposition of explaining to an educated non-specialist how radiative transfer through the atmosphere works. That's very tough, right? If they don't have a background in the physics of radiation, it's really, really hard to do that. And so you're kind of trapped. People say, well, you can't explain it in simple terms, so why do you expect me to believe that? And you don't know what to say. I know it's like I like questioning the pilot of a commercial airliner, but how does a jet work? And he says, well, it might take me a while to explain that to you. And they say, well, I don't want you to fly the jet. That wouldn't be necessarily a rational choice to that. So there are all kinds of strictly scientific challenges, which are the fun part. You get to try to explain something that hasn't been explained before. And then there are the social challenges, which I didn't anticipate when I got into the career. I never thought of it, anything I was studying becoming a social problem. But there's the challenge of communicating to people what you're doing when it's important to do that.
Yeah, and what are your thoughts over like the divide over the issue of climate change in the broader public, and how do you think we can educate everyone on this important issue?
Well, that's wow. I saw that you had written that question. It's a very, very good question to ask and a very hard one to answer. And if we had the answer to that, we wouldn't be where we are now, which is not in a very good place. It's interesting because if you turn the clock back to the 1990s, there was a general concern by then that the climate might be changing, and it was a pretty bipartisan concern. It wasn't divided. Both parties, Democratic, Republican parties, had a long history of concern about the environment and a pretty good history about doing the right thing. I mean, we passed the Clean Air Act, we passed the Montreal Protocols with very strong bipartisan support in both cases. And it all fell apart sort of early in this millennium and became extremely polarized. Of course, it wasn't the only thing that did. But it did, and we can pull our hair out about why that happened, and that's interesting maybe for social scientists. But right now the challenge is, where do we go from here? Where will this partisan divide? My guess is, sorry about the clock there. I can run it, but I can't turn it off. The challenge is how do we actually crawl back from this highly polarized position? I wish I knew the answer to that. My own strategy has been to go around and give, scientific talks, not policy talks, to groups of people who are skeptical about climate change, as opposed to preaching to the converted. And, and I think I've had some success, but how many people can one person talk to? I wish more of my colleagues would do that. But I think one of the things that I've found out from doing this is that if you take an intelligent person, not some bomb thrower, but an intelligent person who says he or she is skeptical, and you really talk to that person, it turns out that they're not really skeptical of science in general, or even of climate science. They're terribly afraid that they're going to have to give up something that they like to combat climate change. They're going to have to give up their big gas guzzling car, or electricity prices will go through the roof, or their standard of living will go down. And I like to point out that that's not necessarily the case, and in fact it might be the opposite. So I talk about the fact that we actually need to be able to produce much more energy per capita if we're going to solve poverty in developed worlds. And we shouldn't be talking about cutting back energy consumption. We should be talking about making that energy consumption clean. And so I try to get people excited about the opportunities. I even talk to them about the joys of driving an electric car. And most people I know, including myself who have one, will never go back to a gas car, even if we hadn't the slightest problem with climate. They're just so much more fun to drive and easier by far to maintain. So life could be getting better, not worse. And as soon as you open up that possibility to people, they they're going to they tend to drop their objections to the science. It's an interesting psychology at work there. But the other thing that happens on the more negative side is more and more people are being hurt by climate change. one way or the other. Either house burns down in a wildfire in California or gets wrecked by an unusually strong hurricane in Florida. There are converts, one at a time. You may or may not know this, but in the late 1930s, when Europe was coming under the shadow of fascism and Franklin Roosevelt was trying to desperately and without success to get the American people interested in combating that, really very, very low success until Pearl Harbor. And Pearl Harbor, if you talk to a military historian, turned out not to be a big deal because the aircraft carriers weren't in port. It was a huge deal psychologically, and it just changed everybody's mind. Maybe they had already been conditioned to it. And what we're seeing now is not one big Pearl Harbor, but lots of little ones. Every time there's a bad storm or a fire or a flood now, rightly or wrongly, people are attributing it to climate change, and that changes minds. After Sandy hit your city, I don't know if you were around to see that, but a lot of people, including the governor of New Jersey at the time, changed their mind about climate change. So it's going in the right direction. As we wish it could go faster, but I'm guardedly optimistic now about the future.
And what would you say your favorite scientific paper or book to write was, and why?
I think my favorite paper to write was a paper pointing out that hurricanes are examples of something called a Carnot cycle. It's a kind of thermodynamic cycle, which you learn about when you take thermodynamic courses, that it's idealized and nobody ever thought there was a real example of it, but it turns out hurricanes are very close to that. And I really had a nice time writing that paper. I don't know why, it was exciting to me, but yeah.
Okay, thank you so much.
Great, thanks so much.
Yeah,
Thank
taking
you.
the time to interview with us. We really appreciate it.
Well, it was a pleasure talking with you, and good luck on your project.
Thank you so
Thank you.
much.
Okay,
Rest of your
cheers.
afternoon.
Bye-bye.